Hello Matthews, Gatos here. In this video I'm just going to go through your practice test for chapter 3. I'll just do all of the questions so you can pause and rewind a question you need to see or fast forward to one that you need to see, just so you can see how all of these are done to answer any of your questions, just to get you guys prepared for tomorrow when you'll have your chapter 3 assignment. Okay, first question. The odds of rain are 2 to 1 against. Okay, if something is against, that means not rain to rain. So 2 ways to not rain to 1 way to rain. So if I want to know the probability of rain, probability needs a total. Well, there's 1 way that I'm getting rain out of a total of 3 ways. So my answer here should just be D. Okay, in the next one, I'm looking at rolling 2 die. Or run 1 die twice, same thing. Which of the following pairs are mutually exclusive? That means the answer to the question, can both happen at the same time, should be no. They both can't happen at the same time. So we'll just go through this. The rolls, both rolls are the same, and the sum of the rolls is even. So here's all the ways I can get the same roll. So if you look at those, if I take the sum, every single one of those sums is even. So can both happen at the same time? Yes, both can happen at the same time. Okay, for the next one, the rolls are the same, and the sum of the rolls is odd. Well, if you look at all of those, we just said they're all even, so they can't be all odd. So the answer to this is no. So these events here are mutually exclusive. Okay, next one. The word school is spelled out using Scrabble tiles. 1 tile is chosen at random. What is the probability that the tile is an O? Okay, well, let's look at how many O's there are. There are 2 out of how many letters in the word school? That's 6. So in lowest terms, that's just 1/3. So C would be your answer. Okay, a 6-sided die is rolled and a coin is tossed. The probability of the die showing an even number and the coin coming up tails can be written in the form 1/m. What's the value of m? Okay, well, these are independent events because the die doesn't affect the coin. So we're looking at the probability of an even number and tails. So that should just be the probability of an even number multiplied by the probability of tails. So half the numbers on the die are even, and half of the sides of the coin are tails. So that would just be 1 out of 4. So the value of m that they're looking for is just 4. Okay, next page. We have Mel's Diner, and it allows you to choose 1 sandwich, 1 drink, 1 cookie for a price of $5.49. If all choices are equally likely, the probability of choosing a meat sandwich with milk and an oatmeal cookie. Okay, let's just think here. So I am going to look at, okay, there are 2 meat sandwiches I could choose from. I am having a oatmeal cookie, 1 way, and I'm having milk. So I'm having one of those guys. I'm having an oatmeal cookie, and I'm having milk. Okay, so those are all the choices out of the total. So the total is 4 sandwiches times by 3 cookie choices times by 3 drink choices. So that will be 2/36, which in lowest terms is 1/18. Okay, we have a committee of 6 students to be selected from 5 boys and 6 girls. The probability there are exactly 2 boys on the committee is what? So if I have 2 boys, that means I must have 4 girls. So 5 boys and I want 2 of them. I'm not assigning roles, tasks, or jobs. That's why it's a combination. Multiplied by the girls, there's 4 girls and I need, 6 girls and I need 4 of them, out of a total of 11 kids, and I need a committee of 6. So I can punch that into my calculator. Oh, actually, I don't even need to punch that into my calculator. There's the answer. Okay. So it says if the probability of A is 0.2, the probability of B is 0.6, the probability of A or B is 0.68, which of the following is true about A and B? So we're talking about mutually exclusive and independent dependent. Okay, so let's see if there is overlap. So what I'm going to do is I'm going to see is the probability of A or B equal to the individual probabilities? If it is, then they are mutually exclusive because both can happen. So the probability of A or B is 0.68, the probability of A is 0.2, and the probability of B is 0.6. So 0.68 does not equal 0.8. So that means there is overlap. So to figure out the overlap, this one here has 0.12 extra. And that extra really means both. So can both happen? Yes, both can happen. So it is not mutually exclusive. So that means I can knock off A and B as an answer. Now I have to figure out if they're independent or dependent. So now that I know the both probability, if the probability of A and B is equal to the individual probabilities multiplied together, if that's true, then they're independent. So let's check. 0.12 equals 0.2 times by 0.6. Now that is true. So since that is true, they are independent. So C will be my answer. Okay, next one, number 7. So the diagram shows sample space of 12 equally likely outcomes. The probability of the complement of M. So M means complement of M is not M. So I know first of all there are 12 in total. So my denominator will be 12. So if I don't want M, let's get rid of it. And let's see what we're left with. We're left with 1, 2, 3, 4, 5. We're left with 5 out of 12 ways that M cannot happen. Okay, the probability of M or N. So there's 12 altogether. And M or N means all the ones in M, or all the ones in N, or all the ones in both. So basically everything except for that guy there. So that would be 11 ways, not counting that one on the outside. So that will be A. Okay, we're going to omit number 9, not part of the curriculum. And let's do number 10. So a computer has rearranged all of the letters in the word Surrey into every possible order. The computer picks one of these arrangements at random. The probability that the chosen arrangement begins with 2 R's. Okay, so this is a permutation question. So I have 1, 2, 3, 4, 5, 6 letters. I have 2 of them are a letter R, no other repeats. So the total ways of arranging things is going to be the 6 factorial ways of arranging the letters divided by the 2 factorial ways of arranging those R's. Okay, now I want to begin with 2 R's. So let's see. 1, 2, 3, 4, 5, 6. I want to begin with 2 R's. So 2 choices for the first R, 1 choice for the next R, and then I have 1, 2, 3, 4 letters left to arrange. So that's 4, 3, 2, 1. So really 2, 1 is 2 factorial. 4, 3, 2, 1 is 4 factorial. So I can plug all of that into my calculator. After, of course, I have to divide this by 2 factorial. Sorry, I forgot that step. Okay, so let me just say why I did that, because the R's are repeated. So remember, you figure out the ways of arranging it without any repetition and then divide by the repetition. So if I have 2 factorial times 4 factorial divided by 2 factorial, that's really just 4 factorial over 6 factorial divided by 2 is actually 360. So this is 24 over 360, which I put into lowest terms, and I get 1/15. So again, always divide by the ways of arranging the repeated elements. Okay, let's look at number 11. So Rory and Luke are playing in the final of a match play golf tournament. On the first hole, they each have a 10-foot putt for birdie. The probability that Rory makes the putt is 0.8. Then the probability that Luke makes the putt is 0.7. These events are independent. Assuming neither player can take more than 2 putts to complete the hole, the odds against Rory making the putt. So if he has a 0.8 probability of making the cut or the putt, that is 8 out of 10 or 4 out of 5 in lowest terms. So the odds against is Rory not making it to Rory making it. So if there are 4 ways that he is going to make it, 5 in total, means there is 1 way that he can't make it. So my answer would be 1 to 4. Okay, the probability they both miss their putt. That's the probability of not Rory and not Luke. And we're told that they're independent, so I can just multiply these together. So this would be the probability of not Rory times the probability of not Luke. So if Rory has a 0.8 chance of making it, he has a 0.2 chance of missing it, 1 minus 0.8. If Luke has a 0.7 chance of making it, he has a 0.3 chance of not making it, 1 minus 0.7. So multiplying those together, I get 0.06. Okay, the probability to the nearest hundredth that Rory wins the hole. Okay, let's think about this. Rory winning the hole. That means that Rory wins it, but also means that Luke doesn't win it. So this is the probability of Rory winning and also at the same time Luke not winning. So that will be the probability of Rory multiplied by the probability of not Luke, because we do have to consider that. Otherwise it would be a tie. So the probability of Rory winning was 0.8. And the probability of Luke not winning was 0.3. Multiply those together and you're going to get 0.24, 0.24. Okay, next one, the probability to the nearest hundredth that neither player wins the hole. So that will be the probability of Rory not winning and the probability of Luke not winning. So again, they're independent, so I can just multiply those together. So the probability of not Rory, 0.2, times the probability of not Luke, 0.3. Multiply those together, and I get 0.06. So that will be my answer to number 3. Oh, wait a second. Let me think. If neither wins, this is them both losing, but if neither wins, a tie technically is that neither person wins. So I have to also look at a tie. Okay, so that would be, we have to add on that one as well. So a tie means neither person wins. So I also have to look at the probability of Rory. Wow, this is a good question. And Luke winning. So the probability of Rory winning times the probability of Luke winning. So that again was 0.8 multiplied by 0.7, which is 0.56. So I have to take 0.56 and add it on to 0.06, and I'll get 0.62. That was a tricky question. Okay, so technically if they tie, neither one is winning. So let's look at number 13. In a recent survey of grade 12 students, it was found that 76% took math, 62% took biology, 93% took math or bio. Then the percentage of students who took bio and not math is what? Okay, so we can look at, let's see, I'm going to say 76 took math and 62 took bio. That should add up to the 93 if there's no overlap. Okay, if you can't take both. Clearly that's not going to happen. So this is 138 and that's 93. So they're not equal. So that means that there is 45 too much. So that's the overlap, which is both. So the ones that took only bio would be all the students taking bio, subtract that overlap of 45, which is the students that took both, and then you would get 17%. Okay, number 14. So we have a tree diagram here. We have school cafeteria selling small baskets of fruit. At the start of the day, the only baskets of fruit were green apples, green grapes, and red grapes. A grade 12 constructed a tree diagram shown to represent the probabilities associated with the baskets of fruit. The first student at the cafeteria bought one of the small baskets of fruit. What is the probability she bought green apples? So looking at this, the probability of buying apples is 2/3. The probability of grapes is 1/3. Of the 2/3 of apples, 1/4 were green, 3/4 were red. Of the grapes, 2/3 were green, 1/3 was red. So we want to know the probability that she bought green apples. So there's two different parts here. This is the probability that she bought apples. We have to look at that, and the probability that they are green times by the probability that they are actually green apples. Okay, so we're looking at the probability that she bought apples. She had a 2 out of 3 chance of buying apples, and of those apples, a quarter of them were green. So multiplying those together, I get 2 out of 12, and in lowest terms, that would be 1/6. Okay, the next one says the odds in favor of her buying red fruit. Okay, well, let's figure out what the probability of buying red fruit is before we can do the odds in favor. Okay, so now for red fruit, let's see. It would have to be apples that are red. Let's do that. So apples that are red. So that is 6 out of 12. Or grapes that are red. 1/3 times 1/3, which is 1/9. Okay, so adding those together, I'm just going to grab my calculator and we'll do my fractions on the calculator. So I've got 6 out of 12 plus 1 out of 9, which is 11 out of 18 in lowest terms. So the odds in favor, remember odds don't have a total. This means 11 ways that they are red and the total is 18. So 18 take away 11 means 7 are not red. So the odds in favor of her buying red fruit are the 11 ways of buying red fruit to the 7 ways of not buying red fruit. So that means that B would be the answer. Okay, so we'll skip number 16 and we'll go to number 17. A card is randomly selected from a deck of 26 red cards, 26 black cards. What is the probability that the card is either red or an ace? Okay, well, let's look at that. So we have 26 out of 52 red cards, and we have 4 out of 52 cards that are red. But remember, there are 2 red aces. So I've counted them in the reds, and I've also counted them in the aces. So I need to subtract 2 out of 52. So that will be 28 out of 52, which in lowest terms is 7 out of 13. Okay, numeric response number 4. So Paul is listening to a playlist of 20 of his favorite songs. He puts his MP3 player on shuffle and listens to 5 of those songs at random. The probability to the nearest hundredth, he gets to listen to exactly 2 of his top 5 favorites. Okay, so really what that means is 2 favorites. Oops, what's going on there? 2 favorites and 3 not favorites. So we're not looking at a specific order, like it has to be the first 2 songs. So it's just looking at, do I get my favorites compared to my not favorites? So this would be a combination because we're not talking about the order in which they're being played. So I have 5 favorites and I want 2 of them. And I have 15 not favorites and I want 3 of them. Out of a total of 20 favorite songs, and I want 5. So plugging that into our calculator, we're going to get 0.29. Okay, omitting the 18, let's go to number 19. So it says, of 10 students on student council, 4 are to be selected to plan an assembly. There are 4 males and 6 females. If Nicholas, the president, must be selected, so we have to have Nicholas, then the probability of having 2 males and 2 females is what? Okay, so we have to select Nicholas, so it's kind of like we're going to just take him completely out of the mix. So when I have my 4 males that I'm choosing 2 from, and I have my 6 females and I'm choosing 2 from, since I want Nicholas to be on there, I'm taking him out of the selection. So really I only have 3 males that I'm choosing from. So I have 3 males and I need 2 of them. I'm not assigning roles, tasks, or positions, so it is a combination, times by 6 females, and I need 2 of them. Out of, altogether, there are 10 students, but I'm taking Nicholas out of the mix, so I have 9 students, and I need 3 of them on a committee, because it is a committee of 4 people, but Nicholas is on there, so it's 9C3. Okay, put that into your calculator, and you would get 15 out of 28. That will be your answer in lowest terms. Okay, number 20. Isabella and Michaela each attempt a 3-point shot in basketball. The probability that Isabella is successful is 0.2. The probability that Michaela misses is 0.85. So the probability that Isabella is successful 0.2. The probability that Michaela does not make the shot is 0.85. These events are independent. What is the probability that both players are successful? So the probability of Isabella and Michaela. So they're independent, so I'm going to multiply them together. So the probability that Isabella is successful is 0.20. Now Michaela, the probability she misses the shot is 0.85, so the probability she makes the shot is 0.15, 1 minus 0.85. So I can multiply those together, and that will give me my answer of 0.03. Okay. Numeric response 5. The probability to the nearest hundredth that only one player is successful. So that could be the probability that Isabella is successful and Michaela isn't, or the probability that Michaela is successful and Isabella isn't. So that will be, because they're independent, I can multiply them again. 0.2 times Isabella's chance of making it is 0.2. So, oh yeah, that's right, 0.2 times, I was confusing myself, 0.85. Or means add, and then Isabella not making it 0.8, which is 1 minus the 0.2, times by Michaela making it 0.15. So I can put all of that into my calculator exactly like that, and I would get 0.29. Okay, the next one, the probability to the nearest hundredth that at most one player is successful. Ooh, this is a good question. So this is that Isabella makes it, Michaela doesn't, or Isabella doesn't make it, but Michaela makes it. Probability that at most one, or neither of them make it. So I can do all of those individual probabilities, or the only thing that I'm not considering is that they both make it. So the only case that I'm not considering is that they both make it. So this total here adds up to 1. So I can do this, this, and this, or I can do 1 minus the probability that they both make it. So I'm going to try that one. Okay, and you guys, if you want to do it the other way, you'll get the same answer. So 1 minus, okay, so Isabella is making it 0.2 chance, and Michaela is making it 0.15 chance. So, and if you want to see the other way, on my detailed solutions on D2L, I did it the first way. So I'm just trying something new, and I get 0.97, which is the same answer. So if you like this way of doing it, on D2L, I have a detailed solution for that. I was just trying something new here. Okay, let's move on to the written response. So we're in the home stretch. Okay, the Broncos, a recreational soccer team, are playing a week-long round-robin tournament with 9 other teams. There is only one field available at this tournament, so 2 teams can play at a time, only 2. If each team plays the other team in the tournament, how many games are scheduled in the round robin? Okay, well, I have 10 choices for my first team, and then 9 choices for my next team, because you can't choose yourself, but they only play each other once. So in this calculation, I'm including, like, for example, A playing team B and B playing team A. So since they're only playing once, I'm going to divide by 2, and that is 45 different team schedules. What is the probability that the Broncos are chosen in the first selected game? Answer as a combination notation and as a reduced fraction. So probability Broncos are chosen. So there's only one Bronco, and I'm choosing that. And then they have to have 9 other teams that they could be paired with. And that's all out of the 10 teams, and I need 2 teams to work. So that would be the combination notation. Putting that in my calculator, in lowest terms, I get 1/5. Okay, in one of the games, the Bronco must play against their rivals, the Knights. Oh, that sounds serious. Based on past experience, Broncos don't perform well when it's raining. So the odds against Broncos winning when facing the Knights are 3-2, and when it's raining, 1-2. Okay, so when it's raining, let me write that out. Odds against Broncos winning when facing the Knights are 3-2 when it's raining. Okay, so it's like a double whammy. The Knights They're rivals and it's raining. So the odds against Broncos winning, that means not winning to winning, would be 3-2. Okay, and then when it is, it's a 1-to-2 ratio when it is not raining. Okay, so this is when it is raining. When it is not raining, the odds against them winning, so Broncos not winning, the odds against is 1-to-2. Okay, so rain and no rain, we got that. Okay, so now use this information to determine that the Broncos will beat the Knights if it's raining. So if it's raining, I want to look at the probability that the Broncos will win. So this is the raining one that I'm looking at. So I have 2 ways of the Broncos winning out of a total of 5 ways. So the probability would be 2/5. The probability of the Broncos winning if it's not raining, that's this over here, is going to be the 2 ways that they win out of the total of 3. Okay. If the forecast is calling for a 40% chance of rain when the Broncos face the Knights, draw a tree diagram to determine the probability that the Broncos will win their game. So there's 2 things going on here. Okay, the first thing is rain or not rain. So 40% chance of rain, which means 60% chance of not rain. So if it's raining right here, remember the probability of the Broncos winning is 2 out of 5. So the probability that the Broncos win, 2 out of 5, which is 0.4, and the probability of the Broncos not winning would be therefore 60%, 0.6. When it's not raining, that's over here, the 2/3, I'm going to have a 2/3 chance of the Broncos winning. So that's 0.66666 repeating. And then the chance of the Broncos not winning would be 0.3 repeating, or 2/3 and 1/3, whichever is better for you. Okay, so looking at this, this is raining and Broncos winning, raining and Broncos not winning, not raining and Broncos winning, not raining and Broncos not winning. So we want to determine the probability that the Broncos will win. So that's going to be this one or this one. So raining and Broncos winning is going to be the 0.4 times the 0.4, which is 0.16. Not raining and Broncos winning is going to be 0.6 times by 0.6 repeating, and that's going to give me 0.4. So add those 2 together, and I'm going to get a 0.56 chance of the Broncos winning their game, whether it's raining or not. And if you want to, you can put this into a fraction. Let's just do that. And it's 14 out of 25 if you prefer a fraction. So, or 14 out of 25. Okay. The favorites to win the tournament are the Celtics. The probability that the Knights will beat the Celtics is 0.34. The probability that the Knights or the Broncos will beat the Celtics is 0.52. The probability that the Knights and the Broncos will beat the Celtics is 0.7. Determine the probability that the Broncos will beat the Celtics. Okay, let me just write this down again. So the probability that the Knights win is 0.34. The probability that the Knights or the Broncos win is 0.52. The probability that the Knights and the Broncos beat them is 0.17. So I just want to know the probability that the Broncos will beat the Celtics. Okay, so I'm going to look at the probability that they both beat them. And that should add up to the probability that the Knights beat them. I'm going to move this over. I'm running out of room. Oops. Let's try that again. Whoa. Sorry, guys. Here we go. I'm just trying to move my writing. Okay, that's not going to work. So I'm just going to move it over myself. Okay, so if I want to know just the probability of the Broncos, so the probability of both of them winning, so the probability of the Knights or the Broncos winning is going to be the probability of the Knights winning plus the probability of the Broncos winning, subtract the probability of both of them winning. So Knights or Broncos, that's 0.52. The probability the Knights win is 0.34. We're trying to figure out the Broncos. Subtract the probability of both winning. Okay, so looking at this, 0.34 take away 0.17 is 0.17 plus the Broncos. So subtract 0.17 from both sides, and I get 0.35 is the chance that the Broncos win. Okay, so that is all of your questions. I hope this video helped, and just let me know if you have any other questions.